All right. Hopefully the stream should be live now. Are we good? All right. Can you hear me on Discord as well? This will be interesting. All right. Yeah, and I do recommend if you can, like, you can join the live stream voice channel if you want to like ask questions or whatever, but unless you want to get a lot of feedback, I would only have either Twitch or the live stream audio going and not both. Twitch does have a brief delay because that's how Twitch works. So just a heads up on that. It's a good question, Mansell. I can change that now, actually. I'm not too concerned if you do it before class today. I mean, things are going to be changing in general quite a bit. So I think pictures or scans will work. I just changed that to online and PDF. Yeah, I'll talk more about our plan once class starts, but yeah, there's going to be, I've got to figure out how to like give feedback properly is going to be the main issue. Also, just a heads up, because of our Wi-Fi and like I am streaming the iPad essentially to like an Apple TV, but actually just to my PC, and it's going to go out occasionally because our Wi-Fi is terrible, and apparently that like is never fixed here. So I'll have to occasionally just like refresh. I have to like turn off my Wi-Fi and turn it back on. So Ricky, since you're in stream, can you hear me all right through Discord? Or Caleb? Oh, what's up, Caleb? Hear the mic? Yeah. Now the question is, can you hear Caleb on stream? Because the goal is no. Awesome. I did it right. Feels good, man. This has been incredibly stressful because I got back at literally 10 p.m. last night and figured this out. Yeah, Twitch is awesome. The bad thing is this is probably going to get me back into streaming gaming, which is a horrible idea. Thanks, Mark. Today, Mark, we are doing the CELO theorems. Should be fun. I mean, you can, Clark. I'm not sure I need it. Just go buy some toilet paper with that. You've heard of this. Alright. Yeah, and I'm getting a new Apple Pencil here. It's on this way today, so my writing is going to be pretty crappy today, but will be much better on Wednesday. Mark, what's your favorite theorem from abstract? Can I put this in a better spot? That's not really working. Yeah, and the Discord thing that Caleb's in right now, the voice channel working together, that's kind of what I envision for either office hours or you guys working together on things if you want to do it, outside of live stream time. Because we'll still try to have office hours and stuff. It'll just probably be like my actual office hours, unless you have like very specific questions, just because I can't just stay online all day. Yeah, Lagrange is very nice. Oh, by the way, I figured out how to win the game, both games on A4 on my flight back. It's actually like super easy, and I think the circuit making game in A4 is generalizable to very symmetric graphs built out of triangles and other n-gons. Which is nice. All right, how many are we missing? So, okay, but some people are on Twitch and not Discord. So I think almost everyone is on. Haven't seen Jose maybe, and Eddie. I'm just gonna spam my own chat. That's fair. So, I mean, you don't need a mic, Clark, but I mean, for the stream, this works just fine. But you can listen to streams as long as you have a headset, or, well, you don't even need a headset, really. To talk, you obviously would need a mic, but there's also a text chat in there, too. Reese. I mean, you can learn some abstract. All right. Well, the good thing about this is even if some people aren't here, it is recorded. That's a super nice thing about Twitch. So let's go ahead and get started. Who is Nightmare Moon? It's a dope name. All right, excellent. Jose is here. So, yeah, obviously things are going to be a bit strange for the rest of the semester. So I imagine, by the way, obviously I have no information on this past the next 2 weeks, but I imagine it's going to be the rest of the semester. At least that's what I'm planning for. Just because I think there's no way we're back in 2 weeks, and if it goes another 2 weeks into the middle of April, then I think why would we bring people back for the last 2 weeks of class? That just seems unlikely to me. So this is what I'm planning on. If we do end up back, then obviously that makes life easier. But planning on it being this. So things obviously will be a little bit different. It's going to be more of me talking to you. Definitely feel free to hop in the live stream voice chat if you want to ask questions in class, or you can ask via text as well, and I'll continue to try to read those. But if you find it hard to type out, which I assume a lot of math questions will be, feel free to hop in the live stream and just unmute yourself if you want to ask a question. The plan is this will be how class works. We'll stream via Twitch. Those are all recorded on my Twitch channel, so you can go back and watch them if you want to. I'll be using my iPad to kind of write out notes. I am getting a better pencil after today, so it'll be easier to read my stuff today. It's going to look like I have very poor fine motor skills. Other stuff on Discord. So I think I'll hold office hours through Discord. And there we can even do direct calls where I can share my screen and use my iPad, but not, have to stream it through Twitch. You can also talk with each other using the working together voice channel or the general text chat in our Discord. So that you guys can collaborate with each other, or ask a general question to me. I'll make announcements in the announcements channel. We will have daily homework still. I want you to try to work through things before coming to class, but we'll move that to like submitting PDFs, and I probably won't give as much feedback on those. At least for now. I may end up writing things on like a PDF editor on my iPad so that I can give you more feedback, because I think it's obviously very inefficient to print those out, write, and then scan them back to you. We will still have problem sets. Problem sets will not be as difficult because, even if I can have office hours through Discord and whatnot, it's going to be impossible to have the same kind of interaction that we have in my office. And so to make those as involved as they have been, I think just isn't very smart. So the plan is to make it more reasonable. And it's probably the same length in terms of number of questions, but just slightly easier questions, maybe slightly closer to what we're doing in the daily homework and less adventuring into new topics. And then test, maybe I'll actually just go ahead and start writing some stuff. So there will be a test next week. It's going to be take home. So, I guess it'll be assigned next week. I'll probably give you a few days on it. There's no real way to turn it in person, so it has to be take home. And I think in this class, since it's rather proof-based, this is going to be doable. I'm not sure exactly the format yet, because obviously I think, having small definitions is unreasonable, because I'm going to let you have like open notes on it, and that would be the easiest question in the world. So I've got to figure out exactly how to do it without making it all proofs. I do want to have some computations in there, and I think that's pretty reasonable. We have some in the daily homework, so I'll figure it out. I think it will work fine, and then you can just submit that via PDF, similar to a problem set, right? So, you can use LaTeX and make it look nice and turn that in. There won't be style points or anything. I am more worried about whether it's correct or not. I don't want you to spend a whole bunch of time editing things in LaTeX. I just want it to be readable. So that's the plan. Yeah, you are right. You're hilarious. By the way, he's my old office mate, for people wondering who the heck this person is trolling our chat. So yeah, that's the plan for that. I will post a study guide today. I don't know exactly what a review session might look like. I guess I can do a review session Twitch stream later this week or something. If that is something that interests you guys, maybe I'll put a little poll in Discord later, or you can just give feedback right now if that sounds like something you would like to do on an evening at home. But that's pretty much the plan. Are there any questions you guys have about like logistics going forward? You can either hop in voice chat, text on Discord, text here, submit homework ahead of class. Yeah, so after today, that will be the plan. Yeah, submit by like 11 a.m. Yeah. It's a good question. Do I want the purple pin stuff after class? Oh, you definitely don't need to buy purple pens. I mean, if you have like any pen, that would be fine. Yeah, Jose. So it would just be via PDF. So if you can scan, like I know Cam Scanner is a good app. Um, I mean, a picture is fine. I kind of prefer one that makes it look like a scan just because it's like easier for me to read. But if it's a high quality photo with good lighting, I am also fine with that. And then it would just be like submit online on Canvas. Um, oh, colloquium points. Sorry, let's address the purple pen thing first. Yeah, I didn't think about that. I think no. Um, I'm probably not going to have you submit two versions, to be honest. Yeah, Notes apps would be perfectly fine as well if you all have iPhones or iPads. Um, yeah, I think we won't necessarily always go exactly through the things. There'll be enough like other lecture notes that I just don't think submitting so many things online is going to be really worth it. I want to see that you are doing work outside beforehand, and then hopefully you're in here watching. I just don't think I can do the same kind of monitoring. It just doesn't seem reasonable. Uh, so colloquiums, or colloquia, that's actually pretty easy. So I will post something about that later, maybe in the next day, maybe not today because I have quite a bit to do, but maybe tonight, maybe tomorrow. The idea there will be I'll post YouTube videos of talks, and basically, and they won't necessarily all be about like abstract algebra or anything, right? Because the colloquia here are not necessarily all about abstract algebra. So basically, I just have you watch a YouTube video that's like a normal colloquium, and then you could write notes on that. So that will be pretty easy and manageable. Other questions? And I can email some like notes out after uh, class on kind of what we talked about in terms of these main points. LaTeX would be well, I'd still want the problem sets in LaTeX, and I'll probably want the test in LaTeX as well. It's just much, much easier to read than handwriting, especially if, depending on what you're using for handwriting and like taking pictures and whatnot. But I won't do style points in the same way. So as long as it's like readable and gets across what you want to say, like I don't care if you have some like weird symbols or something, or your spacing isn't exactly right, like that's fine. All right. Will the problems on the exam be harder than it would be before? No, actually. So I guess maybe a little bit for so I was already going to have an in-class and out-of-class portion for this exam. We just didn't have enough experience with proofs on the first one to do more than just like some basic ones. So this was already going to have a take-home portion, so that will basically just be the same. And then the in-class portion, yeah, it'll probably be ever so slightly more challenging because you'll have more time and open notes, but not insanely so. I would say that would be on the level of some of your like computational daily homework problems, or like the basic small theorems and lemmas in the daily homework, if that makes sense. Uh, Yeah, review session would be via Twitch, and if you guys are interested in that, then I can do one later this week. Probably on an evening, but I mean, maybe even like a later afternoon, because, sports aren't a thing. So, like, at all, ever, anywhere. There's no sports to watch, there's no sports to, like, do. So, Clark, I have no information on that. Am I assuming it? Yeah, kinda. I do think it's likely that we're gone the rest of the semester. But again, that's just me. I have no real basis for that other than what I see happening. Retaking the definition quiz. Yes, I did think about that. So, not like this. So I think I've thought about doing them orally. So basically just like a direct call between us. It would take like 2 to 3 minutes, and I would just have you kind of describe things to me. I guess I have no real way of ensuring that you don't have things up on your screen, but I can probably ask you questions so that if you literally just read off the definition, I will be able to tell. I want you to be able to like explain it, but yeah, that's my idea right now, is just like a direct call with me if you want to retake it, and I can ask you about some certain things. Yeah, Discord does have a screen sharing feature, but the issue, right, is that you can have other screens up. I mean, I have 3 monitors going right now, and I can't see like the paper in front of you, so like I would only be able to see one thing. But yes, Discord has a screen sharing feature if you're in a direct call, and that can hold up to now 50 people. So it could hold the whole class if we really wanted to do like a group chat. But you would have to be friends with everyone, you'd have to be friends with the person inviting you to do that. So like we can't do it through the server, which is why I'm on Twitch. Yes, I did mention a project. I actually have all the project ideas written up, so I will probably post that. And this might now get slightly more weight than like a final, just because stuff is tougher when it's all from home. And I think that you guys can still put together a good project, and are more likely to do that than have an exam that would be exactly the same quality, as if you could talk to me as much in person. So yeah, I will post project info in the next day or two. Again, that will not be due until basically right before finals. But I just want to get a little head start, and I'll have a couple due dates in between. So the idea here with the project is it will be probably 4 to 6 pages. And then the idea, let's see, it's March 16th. So probably in about a week, I want you to choose a project. And then probably another couple weeks, week to 2 weeks, to outline. And while you're outlining, you may find that you like hate your project, and I would still let you, maybe change at that point, as long as it's pretty early on. And so the idea, right, is by early April, you have chosen a project, you have outlined what you're going to talk about, and found sources. So outline/sources. And then you'll have, right before finals to turn it in. Okay. So it'll kind of have a few steps to it. How do you get more space on this thing? This worked yesterday. I hate my life. All right, so that's the plan. Are there other questions here? Is the info about the project on Canvas? It will be. Yeah, it'll be posted for sure. because it will have due dates, and like I'll post all of the, well, I'll post the info about the project in terms of like the logistics, but I'll also post like little blurbs about each of the possible topics, because not all of them, I'm sure, will sound interesting to you. Poggers indeed, my friend. Wait, I don't have better Twitch TV, do I? That's fine. I'll just take Peppy hands. All right. So, are we ready to do mathematics? Also, as someone who is better than me, I've literally never used notes before, and last night I just pressed this like arrow thing a couple of times, and it seemed to like naturally space. How do you scroll the page? Does anyone know? Because I don't want to keep erasing things. Ideally, I just have like long pages of notes that I could even post. Does anyone know how to do that? Good. Well, I mean, we can figure it out as it goes. Okay, so I should get my notes. All right. Cool. Okay, so yeah, I thought we would just kind of go through. I think today these are some pretty good examples. We're going to talk about cyclic groups and just kind of talk about orders of elements and like order of a cyclic group. So order of elements, I think we mentioned like right before break, and so I expect no one to really remember it, but it has essentially two definitions, and we're given one. So the order of an element G is how many elements are in the subgroup generated by it, the cyclic subgroup generated by it. And then we're going to find a little bit later, and this is kind of what we're slowly working towards today, that this is the smallest in, so maybe I'll say the minimum of natural numbers, so like positive powers. So for instance, anything to the zero, just like anything to the zero is 1 for us with like real numbers, we consider any element to the 0th power to be the identity. Maybe try using 2 fingers to scroll down. Okay, I can try that. So it's the minimum positive number such that G to the n is the identity. And so, right, like under that definition, I mean, for both of these, the order of E would be 1, right? Because, well, that is the only element in the cyclic subgroup generated by E, but also the smallest positive power of E, that is E, is the first power, right? So this is all that we're saying there. And so 412 was just practicing with all of these groups that we're like pretty familiar with and seeing what the orders of elements in there are. Okay, so this is 412. And feel free, again, to text questions if you have them, or hop in the voice chat if you want to say it out loud. So for S2, right, we have 2 elements, and I'm just going to never really mention E because this is true for all groups, right? Every group has the identity. It's always order 1. I don't need to repeat it every time. So we would say this has, the elements E and say S. And then what is the order of S? Well, we usually think of this as the reflection, or you flip the order of the 2 coins, or however you want to think about it. But basically you do it twice and you're back to doing nothing, right? So this is order 2. Oh, the screen's not updating? Let me see lonely screen here. Ah, okay, cool. Yep, this is what I expected. This is what I talked about earlier, so turn the Wi-Fi off, back on, screen mirror. Screen off. Zach's lonely screen. All right, should be back. We good? Yeah, there it is. Okay, cool. Yeah, this will happen like a few times. Like I said to some people who were here before, like our Wi-Fi always makes this screw up, and apparently they haven't really found a solution to it, so it's going to happen from time to time. So just like give me a heads up. Yeah, it's the worst. Okay, so lonely screen's cool. It makes me feel like it knows my life. All right. So the second one is R3, right? So we basically have R and R squared as our other two elements. And what are the orders of these? Well, both of them are generators, right? Because we know that R and R inverse do the same thing, and R squared is R inverse. So here, the order of R is the order of R squared is 3. Oh, 2 fingers works. So we're living the dream. So R4, we have something that's a little bit different, right? So we still have 2 generators of this cyclic group, right? So R and R cubed to give us the whole thing. These both have order 4. But then R squared, right? This only has 2 elements in the subgroup generated by it. We get back to the identity because we rotate like 180 degrees, and then we get back to the start. Good question, Mansell. So if I scroll back up here, right, so the order of an element G is defined to be the order of the subgroup generated by it. So it's really about context. So if I want to be talking specifically about a subgroup, I'll use the subgroup notation. But when I'm talking about the order of the element, which could really refer to either of these 2 definitions, which are equivalent, I'm just going to say the order of G, like I have on the left here. Okay? Yeah. Okay, and so this gives us that the order of R squared is 2. Okay, and then, right, we've got the Klein 4. And here we already know this one pretty well, right? This has that nice property that everything is its own inverse. And so here the order of V, the order of H, and the order of VH, or HV if you want to call it that, because it's the same thing, is 2, right? All of them are their own inverses. For our next group, so R5, and I can really do R7 in a very similar way. So when we get to H here in a second, it's basically the same thing. So remember that the reason like R squared is interesting in R4, right, is that 2 divides 4, right? And so you got halfway there, and then you go again. 5 is prime, right? And so R is a generator, its inverse is a generator, so R to the 4th is. So those guys are both order 5. But R squared is as well, because 2 and 5 share no common factors. So you basically go 2, 4, 1, 3, 5. And then those are your 5 elements that you get. And so R squared and then its inverse, R cubed, are also generators. These are all order 5. And I'll just go ahead and say like same for H with R7. Because 7 is also prime. And so basically anything that's not the identity is going to be a generator because 7 is prime. Useful thing to know. And with regards to our last problem set, if you remember the problem where said that cyclic groups, if you have no non-trivial proper subgroups, basically if your subgroup lattice looks like this and has nothing in between, then you have to be cyclic. The groups that look like this are usually cyclic groups, are exactly cyclic groups of prime order. Okay, so this would be cyclic with prime order. So if you have a group of order 29, it's going to be cyclic. It won't have any subgroups in between. And this would be an application of that problem set problem, which is kind of nice. Okay, so now we're on to F. So this is our first one that has like really a few different things. So with R6, we have the things that share no divisors, right? So like r to the 1, well, 1 and 6, obviously the greatest common divisor is 1. R is a generator, so r to the 5th is a generator. But these are actually the only two. So the other ones do share a common divisor greater than 1, right? And so if we look at the subgroup generated by r squared, we get e r squared and r to the 4th. So the order of r squared is 3. But notice, what's the other element in this? It's r to the 4th, right? And if you do that twice, you get r to the 4th, then r to the 8th, which is r squared in R6. And so r to the 4th is also order 3. They generate the same subgroup. You can also view it as being inverses of each other, right? So they generate the same subgroup. And then lastly, we have r cubed, which is our halfway rotation. And so this is order 2. Okay. So D3, I'm probably not going to go through R8 because it's very similar, but we can do D3. We haven't talked about a dihedral yet. So here we know we have R3 inside, right? And so we already know that R and R squared are order 3 because we've done R3 as our first one, or second one. And then we've talked enough about this that we did the subgroup lattice, right? And we saw that every other element was a reflection. And basically, it's your 3 different reflections across the 3 different lines in your triangle, right? So if I have my triangle, then it's like reflect across this line, or this line. They go through like your 3 points of the triangle. And so one is S, one is RS, and one is R squared S. And these are all order 2. They're all reflections. Okay. So yeah, I'm going to go ahead. We already talked about H. I'm going to skip I as well. R8 is very similar to R6, so it's not going to be very illuminating there. What about J though? So we haven't talked that much about like this L8, right? So this is the 3 light switches, right? So you have like our 3 guys, and they're either on or off. And what do we think the order of elements are here? Let me just type yeah. They are all order 2 here, right? Exactly. I mean, they're light switches, right? They're either on or off, and maybe you turn 2 of them simultaneously on, but undoing that, right, you do it again, you toggle back, and they're back off. And if you didn't change anything, then, well, you still don't change it. So these are all order 2, except for the identity, of course. So I'll say except E. And remember, that shouldn't be surprising, right? Because this is like the generalization of V4, right? Because L4 or L2, whatever, I feel like I wasn't consistent with the notation there. The 2 light switches, right? That was isomorphic to V4. And so that one was all order 2. And then this is basically the same thing. We've just extended the notion, right? And so we still have all order 2 elements. How do we write the subgroup? You'd have to name your elements. So we will talk about that more later, but we can do it right now. If you wanted to say this guy is generated by like left, middle, and right toggles, right? Then you could say the subgroup's generated by L, right? The order of L is the order of the subgroup generated by like LM if you want to toggle those 2, and so on, like that. So you could write all of your elements as some combination. And remember, this is like the switches are independent, so it's abelian, so you can always do it in like LMR order if you want. Okay. D4 is very similar to D3. Basically, it's all reflections, again, except for R squared, and R cubed. And then Q8 for L, if you believe that that's an L. So here, what are the orders of elements here? So are there any well, we know it's not cyclic, right? So there's nothing of order 8. Anyone hop in with some order of an element? Do we have anything of order 4? This is probably why I'm going to be talking most of the time. Good. And I can't guilt you by looking at you. Feels bad, man. Yeah, there we go. All right, cool. I is 1, and good, long, yeah, exactly. So I and minus I, right, because they're going to generate the same thing, because they're inverses of each other. So plus or minus I, this has order 4, or both of them have order 4, and exactly, J and K as well. So we have 6 elements of order 4. Our identity, of course, is 1 here, right? And then we have one other element, which is -1, and this has order 2. Okay. And you can kind of see that with the subgroup lattice as well, right? We had, your big group up here, and then you had your 3 at this level. And basically you get the inverses along with these, and then you head down to -1, and then the identity. Cool. All right. So let's go ahead toward 414. So these were looking at the orders of the matrices. So you guys already basically did this last time, so we kind of talked about this a little bit. So I'm just going to be pretty brief because the people who wrote it on that backboard actually wrote down like all of the matrices. Didn't get how we define subgroup. Oh, I was just saying, like, name your generators, whatever you want to name them, right? So here I'm just saying we have our 3 switches. I called them, L for left toggle the left switch, M for the middle, R for the right, and then any element is some combination of these, right? So you've got L, LM, LMR, LR, R, M, MR, and so all of them are order 2. So all of them are just that thing and the identity for their actual subgroups. Cool. Okay, so the order of the matrix 0, -1, -1, 0, this was order 2. Right, so it is its own inverse already. The order of 0, -1, 1, 0. So this guy, actually, when it squares, is the 1 in A. So this squared is 0, -1, -1, 0. And so you basically do this, you do it again, you get back to A, and then, well, A is order 2. So this is essentially like an R squared kind of thing here inside R4, right? So this is going to be order 4. And like this guy would be akin to R squared and R4 for instance. And then C and D, these guys are very easy to see because these are not going to be finite order, right? So this one, if you keep multiplying it, you're never going to get back to the identity. Good question, Eddie. So can inverses be considered part of the order? Yes, absolutely. So the inverse is always in the subgroup generated by it, right? Because the subgroup generated by an element is like all integer powers of that element, and in particular, right, that's going to include the inverse. So, I mean, it's more than just including it in the order. They will always even have the same order because they generate the same subgroup. And that is one of the problems, right? So, I mean, that was one we kind of skipped because it followed immediately, but that is 415, that the order of G is the order of G inverse, and that is exactly because the subgroup generated by G is the subgroup generated by G inverse. Okay. Yeah, so here on C, right, so if you keep multiplying this, you're just going to get powers of 2 up here. You'll never get back to 1 with any positive power or any negative power. It would only be to the 0th power. And so this guy has infinite order. It's basically a copy of Z that you get in there, the cyclic subgroup generated by it. And it's the same thing with this other one, right? So we kind of talked about what powers of this look like, right? You keep adding 2 down here, so your next one would be like 1, 4, 1, 1, 6, 1, 1, 8, 1, and so on. You keep adding in this lower left entry. And so this guy also is going to have infinite order. You can go in both directions. You can subtract 2, subtract 2, subtract 2, or you can add 2, add 2, add 2, and you will get infinitely many. You can think of it as basically having a copy of 2z in exactly this piece and then fixing the 1, 0, 1 in the other entries. Okay, so kind of like 2z there. It probably would be an isomorphism if you want to practice that. Okay, so again, this one wasn't assigned because we are absolutely not going to prove this, but this is something you should know. So the division algorithm, this is massively, massively important in, math in general. It's a number theory concept. So if you take number theory or have taken number theory, this is something you used or will use a ton. And it's very important here with cyclic groups. And so we need to know the statement. Okay, so basically what it says is if m is any integer, and then we don't usually consider division by the negative things. We usually consider division by a positive integer there. So m could be negative while n will be positive for us. Then we can write m as in q plus r, where q is for quotient. Right, so this is basically how many times n goes into m, and then r is your remainder. Aptly named. And what do we know about remainders, right? Like if you divide by 5, your remainder is going to be 0, 1, 2, 3, or 4, right? You're never going to have a remainder bigger than that, and because of how, right, it's not going to be negative either. We can ensure that. And so r is always going to be between 0 and n minus 1. Okay, and so this is very important because it basically like reduces your argument to smaller powers of things. All right, so let's go ahead and try to start applying things. Okay, so we're gonna try to prove 417 here. So 417, right, states that, well, we're gonna have G be a group, and then we'll have a little element G. And so the claim is that the subgroup generated by it is finite, or the order of G is finite, if you want to think of it that way, if and only if there exists some positive power such that G to the n is the identity. Okay, so this kind of makes sense, right? If you had infinitely many powers and you like never got back to the identity, it like wouldn't be cyclic, right? And it'd be like a copy of Z is what it seems like, but then Z is very much not finite. So like intuitively, hopefully this makes sense. But kind of here with this and the next little lemma, we will get the fact that we know exactly what the elements are in this case, and that they're exactly E, G up to the n minus 1th power of G, basically, if you take the smallest power such that this is true. So Let's go ahead and prove this. So we have two directions, right? We have an if and only if statement. Okay, so here, if we're starting with a finite thing, so suppose it has order n, right? We know it's finite. I don't know what its order is, but it's some finite number, okay? So if we assume that this is true, then if I give a list of n plus 1 elements, there has to be a repeat, right? Because there are only n elements there. So that's going to be the crux here. So then the set E, which you can think of as g to the 0, g squared, down to g to the n, has a repeat, right? Because I started with the 0th power, so this is actually a list of n plus 1 things. So I don't know where the repeat is, but basically you can assume, just call it I and j. So like some power is equal to some other power, where without loss of generality, we may as well assume like I is greater than j. Okay, so maybe it's like g to the 7th is g to the 4th, where n is 10 or something like that. But somewhere we have a repeat. Okay, well, what would you do with normal math, right? We know how to cancel it, right? You would like divide by g to the j on each side. And again, here we're not dividing, right? We're doing multiplying by the inverse. So let's actually like do it completely out for this one time. So we get this, g to the j, g to the j inverse. It's like auto-correcting me. So this is E on the right side. And then what is g to the j inverse? Well, g to the j inverse, we proved a long time ago, is g to the minus j, right? And so this becomes g to the I minus j. Okay, but then since I is greater than j, I minus j has to be greater than 0. So I minus j is in n, right? And so I have exactly what I wanted, right? I wanted some positive power such that g to that power was the identity, right? And in this case, my power is I minus j. Does that make sense? Is that g to the I minus j or g to the I minus? It's g to the I minus j. Yeah, so like the all in the power. We cannot use the definition of the order of the element. So if I'm not going to scroll all the way back up. We have not actually proved that second one yet. So right now we only have the definition of the order of the subgroup generated by it. So we're actually working towards proving that, and that is exactly for 20 something. Where is it? Suppose. Oh, yeah, 420. It's exactly 420. Yeah, insert meme here. All right. So we're getting there. We're very close. Okay. So going the other direction, if we know, can we still have the first half of the screen while we do the second half? I mean, kind of. This is maybe as good as I can do. Okay. So now we get that some positive power of G is the identity. Okay, and then what we want is that the subgroup generated by G is finite. So this, we kind of have an idea of like what it should be, right? It should be somewhat related to like this set. But this is where we want to use the division algorithm, right? That like we shouldn't need things past the nth power, because that's where we should start getting repeats. Right, like if it's cyclic and we have hit E, we're like going back and starting to repeat. But how do we actually prove this? So we're going to go ahead and use the division algorithm here. So, right, we know that this guy is exactly, that's the set generated by, it's actually just straight up the set. And here, because the division algorithm is like stated in terms of M and not K, I'm just going to use M here. I know we've used K in the past, where M is in Z. Right? But what do we know about M? By the division algorithm, we know that M is equal to NQ plus R, where, right, this N is in a natural number. So this actually, it works. We're dividing by a positive number. And R is between 0 and N minus 1. So if I write G to the M, I get G to the NQ plus R. And here I'm just going to split this up, right, and just view like the first NQ and the first R. But what is G to the NQ? Well, that's G to the N to the Q. But what's G to the N? It's the identity. And we know that the identity to any power is still the identity, right? And so this is E times G to the R equals G to the R. And so the key here, right, is we use the division algorithm to reduce to just the remainder. Basically, we took away all the times we used it in times and cycled around, and we only look at where we ended up. You know, if you're thinking of the Cayley graph and it's like some N gone, then we forget all the times we looped and we just look at where did we end up with that last path around, right, for the remainder. And so what does this mean? This means we just proved that G, the subgroup generated by G, is a subset of, well, G to the 0, which is E, G down to G to the N minus 1, because any of the elements, right, any G to the M that I start with can be written as one of these guys. And so its order must be less than or equal to N, and so it's finite. Okay. And then we'll finish up with 418 here. It's just a very quick corollary. So here it's if G is a finite group, then for all G and G, there exists some in some positive power such that G to the N is E. Well, here we're just going to apply 417, right? Because if G is finite, so I'll say proof, since G is finite, any subgroup is finite, right? You can't have an infinite subgroup inside a finite group because it's a subset. So we know that the subgroup generated by G is finite for any G and G. And then just apply 417, right? Because that is exactly that statement, right? If we know that is finite, then we know there is some N such that little G to the N is E. Okay. Alrighty, so I'll go ahead and quit the stream here in a second, but I will have office hours this afternoon. So I mean, my usual ones are like 2 to 3. So I'll probably be bouncing between my servers in here, but you can like make use of the voice channels or the chat, and you know, we can do like direct calls or something if we want to share screen and really like talk about a problem or what's going on. Okay. Otherwise, I will send out an email with like a whole bunch of information probably sometime this evening about, you know, projects and also just like the logistics we talked about at the start of the stream today. Okay. So yeah, thanks for watching, guys, and let me know if you have any problems with anything, and we'll figure stuff out. It'll be a work in progress. All right. See you later.